Okay, good afternoon class. So today we will discuss yung solution to your midterm exam and also yung additional miscellaneous topic in designing isolated footing before we designing shallow foundations before we go to the introduction to the deep foundations, which is the specifically the pile foundations. Okay, so let's start itong midterm exam nyo. Okay. Yung problem number 1 is a square footing supports an interior column of 500 millimeters square column supporting a surface dead load of 1/8 kilonewton and a surface live load of 1/250 kilonewtons. The column is built with 24.1 megapascal concrete and should be used 20 millimeter diameter longitudinal bars with FY, which is 415 MPa. So yung depth of the foundation should not exceed to 2 meters, and at the bottom and the preferred thickness of the foundation should be at least 450 millimeters. Okay, the top of the footing will be covered by soil. Okay, yung unit weight ng soil is 18.8, and yung top ng footing will have a 150 mm thick basement floor with unit weight of concrete to be 23.544 kilonewton per cubic meter. Okay, the basement floor has a surcharge loading of 4.8, and the observed value of the ultimate soil bearing capacity was 870 kPa. Okay, and using a factor of safety of 3.0 for the allowable soil bearing capacity. Okay, number 1, determine the recommended width of, okay, it should be width. Okay, width of the square footing in millimeters, and round up your answer to the nearest 25 millimeters. Okay. So yung problem na to is kailangan nyo daw so magde-design kayo from start, then design nyo yung depth of the foundation. Okay. This one. So yung answer natin for problem A, that is 3,575 millimeters. Problem B, that is 775 millimeters, and yung problem C is 125 millimeters. Okay, so start natin yung problem A. So pag nasagutan kasi natin yung problem A and problem B, nasagutan na natin yung problem C. Okay, so problem A muna tayo. So if you imagine the given problems, according to the problem, yung depth of the footing is 2 meters below. So ito yung footing. Okay, then your thickness is at least 450 millimeters. Okay, then the top has a slab of 150 millimeters, concrete slab. Okay, and a surcharge load of 4.8 kPa. Okay, so if you remember how to solve for the area, okay, paano ba mag-solve ng area? Di ba dito tayo ito yung working equation natin, di ba? QE is equals to P over area. Your P is from the allowable stress design or the unfactored load, or in other words, the service loads. Okay, so kailangan muna natin solve yung QE and P to determine the area. Okay, so to solve for QE, so basically that is Q allow minus yung total soil na existing, di ba? Total soil pressure, total pressure na existing. So before we solve for Q allow, so ultimate divided by a factor of safety. So 870 divide 3, you get 290 kPa. So di ba yung ultimate, di ba yung allowable soil bearing capacity has a factor of safety, di ba? That is the definition of allowable soil bearing capacity. So may included na siya na factor of safety. Okay, so therefore, ito yung ating allowable soil pressure. Okay, so determine the Q sub E at yung net. Okay, ibig sabihin, ito yung matitira na soil pressure nyo. Okay, so allowable soil bearing pressure, soil bearing capacity minus the surcharge load. Okay, minus the pressure due to slab. Okay, at the basement. So that is 0.15 times 23.544. Minus the thickness of the footing. So this time, gagamitin muna natin yung minimum thickness of the footing. So ito yung minimum thickness of the footing, 450. So to design our foundation, so gagamitin natin yung minimum thickness muna ng footing, which is 450 millimeters. Okay. Then next is 18.8 should be multiplied. Okay. 18.8 multiplied by the difference of the total height of the footing foundation, which is 2 meters, minus the thickness of the assumed thickness of the footing, which is this one. Okay. So therefore, you have your Q sub E. Then after that, you can now solve for the width. Okay, yung area. Diba yung area natin? That is a square. Okay, so area square. What is the area of the square? That is L squared. Okay, so yung variable ko lang letter B. So QE is equals to P over B squared. Okay, solve for B. You got 3.5506 meters and convert it to millimeters, multiply it to 1,000, you get 3,550.6 millimeters. Okay, according to the problem, round up down natin siya to the nearest 25 millimeters or the nearest 1 inch. Okay, so ano ba yung nearest 1 inch ng 3,550.6, nearest 25 millimeters? So, ang divisibility ng 25 is 25, 50, 75, 100, di ba? So, this time, hindi na siya, lampas na siya ng 3,550. So, therefore, we can use the width of the footing to be 3,575 millimeters. So, this will be your answer for problem 1A. Okay, so to determine the wala dito. To determine the problem 2, okay, problem 2 natin. Okay, this time and this one. Okay. The problem is asking what is the recommended thickness of the square footing using a 75 millimeter and a rebar diameter of 20 millimeters. Okay. So, may hint tayo doon, design based on one-way shear stress capacity and two-way shear stress capacity. So, ang gagawin nyo lang dito, class, okay, hindi ko pala na-save yung ginawa ko kanina. Okay. Ang gagawin natin dito, class, is since now you have your 3,575 millimeters. Okay. So, ito rin 3,575, di ba? Okay, if you try, so try mo yung 450 millimeters mo. Kung pasok siya, nanlalabas niyan sa one-way shear stress pa lang, hindi na siya adequate. So, ibig sabihin, mas mataas na yung capacity to mas mataas yung demand to the capacity. Okay. So, ibig sabihin hindi natin pwedeng gamitin to. Okay. So, kailangan natin gawin is magso-solve tayo ng D. Okay. So, solve mo lang, just equate the demand equals to the capacity in terms of variable D. Okay. So, ang masasolve mo dyan is ano ba value nito? Okay, ang masasolve mo dito na value, so ang capacity naman ng one way is 0.17. Okay, if you recall, the capacity is 0.17 lambda square root of F prime C. Okay, and for the demand, ang gagawin mo lang, susukat ka lang ng D distance dito. Okay. Sukat ka ng D distance. And okay, open ko lang yung isa. Para makita natin yung value. I forgot to save yung aking Excel. Wait lang ha. Okay, this one. Nakikita niyo ba yung yung video? Ayan. So for checking in one way, yan, nakikita niyo ba class yung screen?
Yes po.
Okay. So for checking for one way, just solve it in terms of D. Okay. So gagawin nyo ganito class. Sinolve mo yung D which is equals to for 50 millimeters, yun you try. Hindi siya pumasa. So now solve mo yung required effective depth based on one way and two way. Okay. So, in terms of D, susukat ka lang ng D dito, then B over 2. So, ito yung distance na to, di ba? So, this is basically ito yung D mo in terms of B over 2 and sukat ka ng D distance dito. So, solve mo lang siya in terms of T. Okay? So, para ma-solve yung in terms of D na yun, so I think makukuha nyo naman siya. So, that is, di ba itong distance na to class is, that is B. Okay, itong distance na to is B minus C1 over 2. Tama? Itong distance na to. Okay? So basically may masasolve kang value dyan. Since yung B may value ka, yung C is may value ka. Yun yung width of your column. Yung B is the width of your footing. Okay? So B minus C over 2 may value ka. Minus mo lang siya ng D. Okay, minus mo siya ng D. That is now your X distance. Okay, this X distance. And after that, you can now solve for the one-way shear stress capacity. So ito yung ating demand. Okay, sorry. This will be your capacity. Yung capacity mo is equals to the phi 0.17 square root of F prime C. Okay, so pwede mong gawin in terms of stress or in terms of force. So pwede mong gawin in terms of force. So mag-multiply ka lang ng B times D, or in terms of stress. So wala to, nasa in terms of stress lang sila. And equate it to the actual or to the demand. Okay, so solve mo muna class yung QU. Okay, I think you know how to solve for QU. So 1.2 dead load plus the 1.6 live load divided by the area. After solving your Q sub U, you can now solve for your one-way shear stress. So, di ba? So, your QU, multiply it to your X distance, multiplied it to your B distance. Okay? Ito na yung QU, okay, times X times B. You now have your force. Okay, ito na yung total force mo. Okay, divide it to the shear stress, which is yung B times yung D, di ba? And you now have your, you can now solve for your D, yung effective depth, which is 526 millimeters. Then, according to the problem, the total depth. So, binigay ko na equation that is plus 75 mm concrete cover plus the rebar diameter. So, ito yung value mo, 621. So round up to the nearest 25 millimeters, you have your 625 millimeters. So ito yung required depth based on one way. So check mo na rin based on two way. So the problem is pasok na ba to sa two way capacity. So ang gagawin mo, okay, this one, ito naman yung sa two way. Yan. So ito yung nasa two way natin. Okay? So in terms of variable D again, okay. So unknown pa rin yung D mo. So ang gagawin mo, ito yung actual, then yung capacity. So according to the problem, meron tayong 3 capacities, di ba? Meron tayong 3 capacities. It is the list of the following values. Yung mga following values, di ba? So you have your 0.33 lambda square root of F prime C. Okay. Then you have your 0.17 multiplied by 1 plus 2 over beta square root of f prime c times lambda. And yung 0.083 multiplied by 2 plus alpha s d over bo lambda square root of f prime c. Whereas your alpha s is 40 since our column is in the interior columns. Okay, your beta is the ratio of the long side of the column to the short side of the column. So 500 divide 500, you have your 1.0 beta. Okay, and if you solve for the three capacities, the governing is letter A, yung 0.33 lambda square root of f prime c. So if you go back to the solution, okay, so just equate again the capacity to the demand. So ito yung inyong capacity should be greater than or equal to the demand. Okay, so therefore you have your, in terms of D again, okay, just solve in terms of D, unknown D. You can now have your effective depth, which is 660.8344. I think that is equation, quadratic equation nata to. So you can use your Casio 991 ES or 570 ES or your scientific calculator. Okay, your total depth, so add mo lang yung 25 mm, yung concrete cover na 75, and the main rebar diameter, which is 20, you have your 755.1185 millimeters. Okay, then add mo yung concrete then round up to the nearest 25 millimeters. Okay, ano ba yung mas malapit dito? So hindi mo na pwedeng piliin yung 750 since below siya dun sa criteria mo. So you will use 775 millimeters. Yan yung total depth mo. So 775 ang required based on two-way versus 600, ano ba yung isa? 625 versus 625 based on, if you based on the one way. Yan. So based on two-way, that is 625. So what do you think will govern? So, diba? So kung gagawin mo, pipiliin mo yung 625 millimeters, okay, mako-compensate yung required depth dun sa two-way shear. So ang gagawin mo, piliin mo na lang yung mas malaki, which is the 775, para ma-compromise na yung requirement for the one-way shear stress. Okay, so this is 775. So therefore, the total, the final answer is 775 millimeters. Okay, so ang next problem is determine the spacing. So for the spacing, I think you can now solve. Okay, so kayang-kaya nyo nang i-solve tong spacing na to. So kung solve mo yung spacing, that is just find the moment at this face of the column. Okay, and you see using the solve value of t, okay, and effect and the width b, okay, and you can now solve for the moments on the face of the column, okay, and after getting the moment, solve for rho. Okay, yung rho actual dyan, kapag i-compute nyo, is mas maliit sa rho min 1. Okay, so therefore, rho min 1 yung nag-govern kasi that is less than 30.36 megapascal. Okay, so therefore, your spacing is equals to how many pieces of rebar. Okay, so gagawin nyo, the total length divided by how many pieces, yan yung inyong spacing. Okay, so yan yung spacing mo. So pieces minus 1, total pieces minus 1. Okay, so basically para lang siyang AB times the width B over the the AS, tamang AB, okay, multiplied by B times AS over AS. So that is your spacing. Okay, so that is how you solve for the problem 1. Okay, and yung next problem natin is number 2. Yung wall footing is to be constructed on a clay which is 0.7 meters below the ground surface, and the footing is supported by a wall that imposes an allowable load of 135 kilonewton per linear meter of the wall length. And the unit weight of your soil is 17.3 kilonewton per cubic meter with a cohesion of 15 kPa. So considering that Terzaghi's general shear failure, which is NC and Q and N gamma, determine the footing width. Okay, when you provide a factor of safety of 3, the ultimate bearing capacity if the width is 0.9 meters, and the new factor of safety using the width of 0.9 meters. Okay. So this problem too is already in the practice problem, okay, or in the example problem that I provided in your yung link sa video. So I think most of you naman nakakuha ng problem 2. So I think I don't need to discuss this problem 2. Okay. So the last problem is problem 3. Okay, yung problem 3 is almost the same dun sa a given example in your module, I think module 16, which is the actual load with bending. Okay, so this one is determine daw the nominal beam shear stress, the punching shear stress, and the maximum design moment when your footing is subjected to P over A, which is the actual load, okay, plus minus the 6M over BD squared, which is the moment. Okay. So, hindi ko na nabanggit dito yung use envelope method. Okay, ibig sabihin, kukunin mo yung maximum PU in each load combination. Okay, so yung PU natin comes from this value, and your MU comes from this value. Okay, so you have your PU and MU. Okay, meron ka ng PU and MU. So next, after that, ang gagawin nyo na is solve for the actual soil pressure. Okay, so to determine the actual soil pressure, so P over A, negative P over A, plus minus the 6M over BD squared, BL squared. Okay, baka malito kayo sa BD. So ito yung B and L. So since that is a square, so B cube. Okay. So yan yung inyong pag-solve for the soil actual soil pressure using your the solve for PU comes from the 1.4 1.7, which is 14 kilonewton, and your MU comes from the load combination 1.3 plus 1.1 plus 1.1. You have your 33 kilonewton meter. And if you solve for the area the soil pressure, so ito yung magiging soil pressure niyan. So alam niyo naman yung pressure diagram when you have your combined axial with bending. Okay. So this will be 307.85, and this is 270.66 kPa. Okay, so that is your pressure. So to determine, number 1, to determine the nominal beam shear stress, so basically hahanapin nyo lang yung pressure at the D distance from the face. So pressure dito, and ito, solve mo yung area na to. And you can now solve for the shear stress, actual shear stress, shear force V sub W. And after that, you know, solve for the stresses, actual stresses. So yung value dyan is based on linear regression, that is 299.14 kPa. Okay, I think you know how to solve for this pressure. So gagawin nyo lang dyan para equation of the line. Okay. Then after that, after solving for this one, okay, number 2, is determine the punching shear stress. Okay, to determine the punching shear stress, ang gagawin nyo lang din is just measure d over 2 distance from each face of the column. Okay, so gagawin nyo is ito yung d over 2 distance, this is the other d over 2 distance, and ito yung soil pressure na sa solve nyo. Okay, and basically that is 282.41 and the 296.1 kPa. Okay, then summation forces vertical, you can now solve for your VU sub P, which is 22 kilonewton. Okay, after solving for VU sub P, you can now solve for the actual two-way shear stress. And lastly, the maximum design moment. Okay, so the same pressure diagram, the only problem is ano yung actual moment na madudulot nito sa face of our column, since 'di ba yung critical section ng moment is at the face of the column. So ito yung face of the column. Okay, yung pressure at the face of the column is okay, ang value nun is I think that is 293. Hindi ko siya okay, I think 293.06. Okay, kung ito ay 307.85, this is 293.06. Okay, then ang gagawin nyo dito ay sa summation for summation moment at the face of the column. So just take summation moment. So hatiin ko na to into pressure diagram. So take moment. Ito yung distances. Okay, and you now have your actual moment or the design moment, which is equals to the 255.11 kilonewton meter. Okay, so that is how you solve our midterm exam. So do you have any concerns and clarifications sa solution sa problem sa midterm exam? Hello, class? Hello? Hello? Can you hear me?
Yes, sir. Wala naman po.
Okay. So, wala kasi akong file ng solution So, hindi ko siya nagawan. And maybe you can verify na lang yung video na to. So, to check the solution for the midterm exam. Okay, so basta ito yung answer. 3575, 775, 125. I think the actual value of this one is 130 plus. Okay, so 130 millimeters. So hindi mo naman pwedeng umakyat mas mahaba mas malalaki yung spacing. Dapat mas masinsin yung spacing. Mas masinsin, much better. So therefore we go down to 125 millimeters. So that is the nearest 25 millimeters. Okay. Ayan. And so maybe we can go to we can now go to your miscellaneous topic. Okay. So this topic kasi I don't pinag-isipan ko siya last week kung ihahabol ko ba yung topic na to doon sa sa total coverage of your midterm exam. Medyo nahahabaan na ako. So hindi ko na muna siya sinama. Okay, so this topic, yan, can you, di ba pala, naka-share screen. Ayan. So this topic is only for the miscellaneous topic for shallow foundation. So ito ay only for the PCG class. Okay, so this topic is a soil bearing capacity for eccentric foundation. Okay, so if you remember how to solve for the soil bearing capacity of shallow foundations. So di ba meron tayong dalawa, si Terzaghi and modified Terzaghi, di ba? Naalala niyo si Terzaghi and si modified Terzaghi. So di ba si Terzaghi binigay yung equation, ayan. Pagdating dun sa modified Terzaghi, okay, ang nangyari, nag-introduce sila ng panibagong factors, which is the inclination factor, if you recall, the shape factor, and the depth factor, di ba? Yun yung equation. Okay. So this time, lahat ng formula na yun na discuss doon is only for actually loaded foundation or non-eccentric foundation. Okay? So ibig sabihin walang moments. Okay, walang moments. So the question is, especially you are maybe someday you're becoming the geotechnical engineer. So basically you will provide the soil bearing capacity for eccentric foundation. Okay. So iba kasi yung assumption, iba rin yung pagsosolve when you are solving for the capacity of actually loaded foundation versus the eccentric foundation. So kailan nagkakaroon ng eccentric foundation? So kapag basically ito yung real life scenario. Kasi yung actually loaded foundation, or yung non-eccentric foundation is purely theoretical. This is only for theoretical and hindi ito existing sa real life. Bakit? Hindi naman perfect yung pagkakagawa sa lahat ng mga project. Hindi perfect yung spacing, may mga discrepancy yan. Hindi perfect yung na-produce na compressive strength, minsan mas mataas. Okay, most of the time mas mataas. Okay? Bihira lang yung mas mababa. So especially for kapag napapansin niyo yan, let's say bumili ka ng concrete compressive strength na 3,000 PSI. So kapag nagkanda ka ng UTM, may mga samples nyo, hindi siya 3,000 PSI talaga. Umaabot pa siya ng 4,000 PSI. So mas mataas pa pala yung actual capacity. So which is good, 'di ba? Pero the actual specs is 3,000 PSI. So doon ka lang naman nag-design sa inyong mga cases. Also yung mga rebar strength. Yung mga rebar strength natin, hindi yan actually grade FY na naka-indicate. Minsan yan, mas mataas yan ng 25%. So minsan nagkakaroon ng 1.25 FY assumption for the actual strength. So basically, at the end of the discussion, ang ibig ko sabihin is hindi perfect yung pagkaka-construct. So yung actually loaded foundation or yung no moments, parang walang eccentricity, is hindi talaga existing in real life. Always may eccentric foundation. Okay, so kung ganon, kailan ba natin i-consider ka eccentric foundation siya or consider natin siya na actually loaded foundation? I-consider mo siya na eccentric foundation when the designer, let's say the structural engineer, design the building, assume the building when having a fixed base. Yun yung assumption niya, fixed base. And also, pwede rin na the actual moments is very large that mas mataas na sa minimum. So let's say ang minimum kasi na eccentricity sa column is, reinforced concrete column is 0.10H and 0.15H. 0.10H, 10% of the total length is the minimum eccentricity for the RC column na tied, and 15H or 15% of the total length para doon naman sa spiral. Okay, sa mga spiral RC column. So yun yung mga criteria kung kailan ka magko-consider ng eccentric foundation. Okay. So ayan. So kailan natin paano natin solve yung soil bearing capacity for eccentric foundation? So this topic is hindi siya natatakel sa other classes, sa ibang classes ng actually itong topic na to hindi na-discuss sa amin nung nag-aaral pa ako nung college. Okay. So to solve for the soil bearing capacity of eccentric foundation. So this topic is excerpt from the Principles of Geotechnical Engineering by Brahadas. Okay. The question is, what is the bearing capacity of foundation under eccentric loading or axial with moments? Very large moments. Okay. So, number one case is one-way eccentricity or yung single axis bending. So, di ba naalala nyo, nakapag-solve ka na ng demand. You know how to solve for the demand. Okay, di ba naalala nyo yung topic natin, module 16, yung P over A plus minus 6M over BL squared. Okay. And ito yung pressure, di ba? Actual soil pressure. For one-way eccentricity, and for two-way eccentricity, lalagyan mo lang siya ng my. Yan, ganyan lang. Okay. So for ito yung pag-solve for the demand. So ito naman yung pag-solve for the capacity. Yung di-discuss natin ngayon. So di ba the basic principle of civil engineer or the structural engineering is basically kahit sa geotechnical engineering din is basically the total demand versus the total capacity. Yan, ganyan lang naglalaro yan. Okay. So for the ultimate load for shallow foundation under eccentric loading, okay. So to one-way eccentricity, to calculate the bearing capacity of shallow foundations with eccentric loading, the Meyerhof 1953 introduced the concept of the effective area. Okay, may inintroduce sila ng effective area. So this concept can be explained with reference to this figure. Okay, this figure with a long length L and a long length B, and is subjected. Hello? Ayan, nawala ako. Can you hear me, class? Hello? Ayan. Okay na ba? Nakikita nyo na yung screen?
Yes po.
Okay. So, ayan. So, the Meyerhof in 1953 introduced this effective area concept. Okay. So, paano ba yung effective area concept? So, for example, meron kang bending in X. So, bending in X, one-way eccentricity, bending in X lang. So, bending in X, so basically, ang eccentricity mo is in the X-axis. Okay. Sorry, bending in Y. So, kasi yung eccentricity in X, magkakos ng moment in Y. Bakit? Kasi 'di ba isipin mo ha, bangka, isa tong bangka, platform ng boat. Ito yung center line of the boat. Kapag nag-apply ka ng load dito, anong mangyayari sa bangka? Ang mangyayari sa bangka magta-topple over siya on this side. So anong cause ng moment niya, which is my. 'Di ba? Nag-cause ng moment yan dito. So that is my. Okay? And this one will cause a moment in X. So isipin mo ulit yung bangka. Ito yung center line ng bangka. So punta mo dito, point load ka dito sa isang side. Anong mangyayari sa bangka? Aangat itong side na to. So this will cause a moment on X-axis. Okay. So again, the moment in Y, the eccentricity is in X. The moment in X is the eccentricity is on Y-axis. Okay, baliktaran sila. Okay. So the effective area concept is referring to the distance E. Okay, ang gagawin kasi, ang ibig sabihin pala nun, hindi yung total length, hindi yung total area yung effective sa soil bearing capacity. So since may moment yan, magkakaroon niya ng contact point kung saan doon yung mas magdidiin niya sa isang side, tama 'di ba? Magdidiin niya sa isang side. So yung isang side na yun lang yung effective. So ano yung distance na yun? So basically, kung ano yung length E na to, ito lang din yung length E na yun. Parang binawasan mo lang yung E doon sa kabila ng E yung length na to. Okay? So paano ba gawin yan? So basically, total length B, okay, total length B, okay, minus your okay, ito yung length B minus 2E. So that is the total length X. Okay. So B minus 2E. So basically ibig sabihin ito ay 2E. Okay? So, ayan. So, burahin ko lang ito. So, ang nangyari pala is meron kang twice of the eccentricity na ibabawas dun sa length on the other side. Ito ay 2e. Okay? So, ang gagawin nyo, total length b minus 2e. Ito yung total length x, which is yung b prime. And this will be your effective area in the bending in y. Yan. Yan lang yung area na yan. Okay. Itong area lang na to. Yan. Then for the bending in x, ganun din. Sukat ka lang din ng the length 2e on the other side. So ito, length 2e. Okay. So kung ito ay L, bawasan mo ng 2e twice the eccentricity, ito na yung length na to. And itong distance na to is yung B. Okay. So itong length na to, ito is the same as B. Ito naging L prime. Okay. Yung length na to, yung B mo nabawasan, naging B prime. And this one is the same for L, which is L. Okay. Yan po yung one-way eccentricity effective area. So the formula is x equals b minus 2e and y is equals to L. And isa pang for bending in x naman, y is equals to L minus 2e, x equals to b. Okay? So that is the effective area for one-way eccentricity. Okay? And what is the formula? So yung length na x and y is can be converted to b prime and L prime. So the lower of the two effective dimensions will be your b prime and the larger of the two dimensions is L prime. So na-solve mo na yung x and y. Okay? Pipiliin mo sa kanila sino yung B prime and L prime. B prime is always smaller and L prime is always larger. Okay. Then, how to solve for the effective area B prime? So, if you recall the modified Terzaghi bearing capacity with no inclination factor. Bakit wala ng inclination factor? Kasi po ay eccentric na yung footing mo. So, wala ng inclination factor. So kapag tinanggal yung inclination factor, mawawala itong okay. Hello. Hello. Okay pa ba sa inyo yung yung dating ng connection ko? Or nagpuputol-putol siya?
Hindi po sir, dire-diretso yung salita niyo po. Nawawala lang po kayo po.
Okay. Hindi naman siya putol-putol. Sige. Okay, so ayun yung equation natin. Okay. So this will be equal to this one. So ito kasi galing to sa ibang book kaya nakalagay lang na F. Pero ito the same lang naman sila. So itong notation lang naman na lambda, pinalitan lang siya na lambda. Okay. So the effective area is equals to this equation. So basically, alam niyo na kung paano gamitin yan. C prime, lambda CS, lambda CD, and C plus Q, lambda QS, lambda QD, and Q plus 1/2 lambda alpha S, lambda alpha D, alpha B prime, B prime and gamma. Okay, so the modified Terzaghi bearing capacity. So yung value of the NC, NQ, and N gamma comes from the equation of Reisner, Prandtl, and yung isa doon sa modified Terzaghi bearing capacity equation. Okay. So doon niyo siya ma-check, and the phi factor is base dito sa yung NC value nito is galing sa phi factor. Okay. And B prime, take note of this one. ginamit na yung equation na B prime. Okay. So next natin, once the value of your Q sub U is calculated in this equation, multiplied it to your B prime and L prime, you now have your total force. And A prime is the effective area. Okay. So mas maganda dyan, okay. So what if other properties naman for the bearing capacity of eccentric foundation for granular soils. So again, it is under a single axis bending. So this time, granular soils naman, medyo mas maano yung inyong foundation. Mas malakas yung inyong foundation kasi granular soils na. So for Cayasta and Char in 1977 carried out the stability analysis for eccentrically loaded continuous foundation on granular soil. So using the method of slices based on that analysis, they proposed this equation. So 1 minus your RK is the reduction factor Q sub U in eccentric divided by the Q sub U for eccentric loading. Okay? So reduction factor kasi siya, nabawasan siya from 100% to a factor of the ratio of QU eccentric and QU centric. The QU eccentric is basically the ultimate bearing capacity of eccentrically loaded continuous foundation. And the QU centric is the ultimate bearing capacity of centrally loaded or no eccentricity continuous foundation. And your magnitude RK can also be expressed as alpha E over B raised to K, where your A and K are the functions of the embedment ratio dF over B, this one, which is table 16.4. Hence, the combining equation is equals to this equation. QU eccentric, or the soil bearing capacity for the eccentric foundation, is equals to the QU centric multiplied by a factor 1 minus alpha E over B raised to K. So these all equations are based on this table 16.4, or the variations of A and K. Okay. Then for two-way eccentricity or doubly axis bending. So the same concept, it is the effective area concept, but this time hindi na siya rectangular. Okay? Ang pinagkaiba lang nila dito is the same dun sa lahat. Okay, ang pinagkaiba lang yung B prime and L prime. Okay. So since dito meron kang eccentricity in X and eccentricity in Y. So if we take zoom in natin dito, yan. So ito yung eccentricity mo in Y and the eccentricity mo in X. Okay. So since may eccentricity ka sa X, so di ba pag may eccentricity ka sa X, ganito siya, di ba? Yan. Then since may eccentricity ka sa Y, ibig sabihin mababawasan dito. Okay. So mangyayari sa kanya is ganito. Okay? So basically kapag yung nasa taas yung inyong EX, papasok ito sa loob. Okay? Kapag nasa baba yung inyong eccentricity, nandito naman, ito naman yung papasok sa loob. Yan, ganyan. Okay? And kapag sa right, sino yung nasa right, sino yung nasa left, siya rin yung magiging value. Sino yung papasok dun sa magkakaroon ng ganitong effective area. Okay. So for EX and EY, the same naman yung pagsosolve. This is also twice the eccentricity. And this is also okay. Itong distance na to is twice the eccentricity. And yung distance na to is Hello, hello. Nawawala talaga ako. Hindi ko alam bakit. Nakakainis. Okay. Lapit na tayo, class. Ayan. Hindi naman nagpuputol-putol, no? Nawawala lang talaga. Ayan. Can you see now my screen?
Yes po.
Okay. So, ayun yung anyong equation. So, just solve for x equals to b minus 2e, and yung L is, or yung y is L minus 2e. Always ganyan. So, you just solve for this one. Okay. And, sige, let's start. So, for example, problem 16.4. So, this is example for problem excerpt from Braha MDAS. Okay. So yung rectangular footing 1.5 by 1 meter is shown in this figure, figure 16.14. So determine the gross ultimate load applied eccentrically for bearing capacity failure in soil. Okay. So ang initial assumptions nila is magkakaroon na ng eccentric foundation, and hinahanap sa geotechnical engineer yung bearing capacity of that eccentric foundation. Okay. So since this is one way eccentricity, or only eccentricity in single axis, so ano yung magko-cause ng bending dito? That is cause bending in y. Okay, tama. And what is the effective area? Tama ba na ito yung effective area dito? Ayan. Yan yung effective area. Okay. So if that is your effective area, so given yung E mo, which is equals to 0.1 meters, and all your the soil properties, okay, 18 kilonewton per cubic meter, 0 and 30 degrees. Okay, and the length is 1.5 meters. Okay. Okay, and your the depth of your foundation is 1 meter below the natural grade line. Okay. So for the solution, your x is equals to b minus 2e. So basically 1 minus 2 times e, that is 0.8 meters. And your y is L, which is equals to 1.5. Hindi naman nabago yung 1.5 meters mo. 1.5 meters pa rin yan. Okay? And therefore, your effective width, okay, di ba pipili ka dyan kasi sino yung B prime and L prime. Di ba? Yung B prime is always smaller and L prime is the larger. Okay, yung 0.8 is yung B prime and yung L prime mo is 1.5. Okay? And now, check mo yung equation. Okay. Yung equation natin is this one. Since there is no cohesion, so mawawala itong first term. So second and third term lang yung magiging present. Okay. So therefore, you have this Q sub U is equals to Q, the shape factor and the depth factor, and Q plus 1/2 the shape factor and the depth factor, gamma B prime and gamma. Okay. So the same lang naman yung shape factor nito and yung depth factor. So you can review dun sa ano natin yung shape and the depth factor. Then for the shape factor, using FE of 30 degrees, the NQ of 18.4 and the N gamma of 22.4. So for the shape factor, that is 1 plus B prime L prime tangent phi. So that is 1 plus 0.8 over 1.5 tangent 30, that is equivalent to 1.308. Another shape factor, that is 1 minus 0.4 df over b, 0.8 over b prime over L prime. So that is equals to 0.787. Then for the depth factor, so 1 plus 2 tangent phi prime, or also equals to 1 minus sine phi squared df over b. Okay, and this has a correction. It should be 1.0. Okay, correction, this should be 1.0 since yung B mo ngayon ay 1.0. Ano ba yung B? Ito yung B mo eh. Yung width B mo na 1 meters. Okay, yung DF mo naman is 1 meters then. Okay, so it has a correction. So anyway, your lambda depth is 1.29 and your depth factor is 1. So therefore, your QU, so lagay mo lang lahat. Q, what that is 1 times 18 kilonewton per cubic meter multiplied by 1.308 for the shape factor multiplied by 1.289 times the NQ, which is 18.4 plus 1/2 shape factor 0.787. The depth factor, the other depth factor is 1.0. Okay, the gamma B prime, your gamma is 18 kilonewton per cubic meter. Your B prime is 0.8 and multiplied it to N gamma, that is 22.4. You have 685.335 kilonewton per square meter or kilopascal. Hence, the equation 16.45, okay, yung equation mo kanina, to determine the total force is Q sub U times the effective area, which is B prime times L prime, or yung area na to. That is the total force. Therefore, the total force is it should be it should be 822.401 kilonewton. Okay, another example problem. Ayan, do you have questions for this one? Okay. Maybe nagtataka kayo saan nanggaling itong mga depth and shape factors. So just verify it in the module for the modified Terzaghi. Okay. So modified Terzaghi lang po ito. Okay. So for example problem 2, consider an eccentrically loaded continuous foundation supported in a granular soil. Yan, granular soil ka na. Yung given properties and dimensions are B is equals to 1.5 meters. The D sub F or the depth of the foundation is 0.75 meters. The load eccentricity E over B is 0.1. Your gamma is 17.5 kilonewton per cubic meter. And your V prime is 30 degrees. And the cohesion value is 0 kPa. Using the reduction method or reduction factor method, which is for granular soil. So, yung one-way eccentricity for granular soil. Okay. Determine the gross ultimate load per unit length of the foundation. Okay. So, using that equation, ito yung working equation natin. Yung QU eccentric is equals to the QU centric multiplied by the factor 1 minus alpha E over B raised to K. Okay. So, also, we can say that your DF over B is 0.5. And if we go back, yung DF over B, which is 0.5, okay, the factor is 1.754 and 0.8. Sir, question, what if your DF over B is wala dito sa value na to? You can use linear interpolation. Okay. So, so ito yung value mo, 1.754 and 0.8 for your alpha and K. So, ito yung sagot niyo. Alpha, that is 1.754. Your K is equals to 0.8. Therefore, your QU centric, okay, sorry, your values is this one. So you can easily solve for 1 minus alpha raised to E multiplied by E over B raised to K. Okay, and solve for QU centric. So how to solve for QU centric? So again, using the modified Terzaghi, okay. So Q and Q lambda Q QD plus 1/2 lambda QDB and gamma, okay. And the shape factor are all equal to 1 since it is a continuous foundation. Okay, take note of this one since it is a continuous foundation or a strip footing, all the shape factor is equals to 1. Okay. Therefore, your QU eccentric is ito galing from the modified Terzaghi. So the shape, the depth factor, and this one, the depth factor. Okay. So using your phi factor of 30 degrees and Q is 18.4 and 22.4. Again, this is from the modified Terzaghi. Therefore, your QU centric is 439.65 kilonewton per meter. Okay, hence, your QU eccentric is equals to this equation or this value multiplied by 1 minus alpha. Ano yung alpha mo? That is 1.754. Okay? And ito. Yan yung value mo doon sa table. Okay? And ano yung E over B mo? According to the problem, your E over B is 0.1. That's 1. Okay? So that is 0.1 raised to K. Ano yung K mo? Yung K mo is 0.8. Okay. So therefore, your value is 317.4 kilonewton. Okay. So ito yung value for your eccentric foundation, which is 317 kilonewton per meter. So this is how you solve for the eccentric foundation for one-way eccentricity. So maybe next meeting, I can find example problem for two-way eccentricity. So hindi ko mahanap kasi kung saan yung example problem for the two-way eccentricity. But maybe next meeting, I can provide yung two-way eccentricity. Okay. So what can you see? So before we end, what can you conclude between the difference yung QU-centric and QU-eccentric? Okay, ito yung QU-centric, 439.65. Yung QU-centric is 317 kilonewton meter. Okay, what can you say? Ang ibig sabihin lang nito, kapag nagkakaroon ng eccentricity, is mababawasan yung actual load na nabubuhatin niya. Okay. So bakit ganoon? Bakit mababawasan? Kasi 'di ba, kapag isipin niyo lang yung stress na to, yung scenario na to. So for example, meron ka lang load dito. May load ka lang diyan. So assuming eccentric to, okay, no eccentricity. So lahat 'yan is mag-act dun sa soil. So this is uniform lahat yung pressure. Okay. Next, kapag nilagyan ko na siya ng moment, so let's say very large moment. Yan, very large moment. What do you think will happen to the load P? So kung malaki yung moment, yung P yung pressure or yung compressive force na binubuhat netong ating foundation is mababawasan kasi yung M para siyang righting moment eh. So malaki yung righting moment mo. Okay. So parang aangat siya, parang aangat yung foundation mo, 'di ba? So parang nabawasan yung bigat na binubuhat niya pababa due to that load P. Pero doon sa isang side, parang kunyari ganito yung moment, doon sa isang side, nadidiin naman siya dito. Sobrang napupush down siya dito. Pero yung on the other side, parang umaangat siya na onte. Okay? So therefore, we can conclude that kapag may eccentricity, nababawasan yung axial force na binubuhat ng ating column, ng ating foundation. Kasi same cases din ito sa column eh. The eccentricity in the column reduces the moment in the column reduces the axial force that the column carries. Okay. So the same din sa any structural member. Kapag meron kayong interaction ng axial and moments, okay, ang nangyayari, nababawasan yung axial, napupunta dun sa napapaangat yung structure and napupunta dun sa moments. Okay? So ayan po. Okay, so do you have any questions regarding this topic? So, yung two-way eccentricity, so I can provide it maybe next meeting. So, for one-way eccentricity lang muna tayo. Okay, any more questions, guys? Okay. So for the midterm exam, maybe I can finish the checking your exam within the week. Okay, ano yung i-consult mo, Miss? Okay, ano yung i-consult nyo?
Ay, sir, kami po, yung ka-group ko po sana. Para po sana po sa thesis about soil erosion lang po. If
Actually,
payag po kayo, sir.
Actually, wala akong wala akong idea about the soil erosion. Sige, pwede naman pag-usapan natin. Titingnan ko lang kung ano yung may input.
Kailan ka po pwede, sir?
Maybe 10 to consultation.
Sa Wednesday po, sir.
Pwede 11 to 12.
Sige po, sir.
Email mo na lang ako at that time so I can give you maybe we can prepare na lang ng Zoom meeting.
Sige po, sir. Thank you po.
Okay. Sige, that's it for today and thank you for listening. So we have class on Friday pala class ha. Okay, thank you.
Thank you, sir.
Thank you po.